square plus 2x plus 3. Is it continuous?
Yes.
Yes, sir.
So it's Borel-Bajor. And we know that every continuous map is Borel-Bajor. So it's Borel-Bajor. And if I compose this with x,
Yes.
then this result is telling me that it's measurable.
Yes, sir.
And hence this guy is measurable.
Okay, sir.
Then you know the all kind of crazy functions, okay, they are all measurable.
e power minus 6.
E power minus x, just name it out. Are you getting the point? So it seems so innocent result,
Sir, it's very powerful.
but it's very powerful.
Sign of x is measurable.
Not,
The sign
is sign not continuous actually.
Sin x.
So everything that is continuous is measurable. Okay?
Take h is
But it's not necessary that everything that is Borel measurable must be continuous actually. So it's like this works even for more powerful things actually. So even I can define a piecewise function, okay, which is not continuous directly, but at least Borel measurable. Are you getting the point? It's a beautiful, nice result actually. So this is what is an important thing that we should. Whenever we are doing a result, we must reflect upon it that what this result is offering to us. The consequence of this result. There are exercises here in this chapter, okay, 2.1, 2.3, 2.4. They are by default exercises for you. So you have to do this as well. Yes, chapter 2 of probability for finance. Okay. I also gave this question in exam that if x is a random variable, but I want to put it there so that everyone can see that if x is a random variable, okay, then x naturally induces a probability measure and hence a probability space. So imagine I have omega fp, f space and x is a random variable in it actually. Okay. Then I can, so it's like for this x or this x induces a probability measure.
Yes.
Okay, so that would be px actually, and px would be a map from where to where? From Borel sigma algebra into the one actually. Okay. And what would be the meaning of px being operated onto
something.
a Borel set would be the probability, if that probability operated onto x inverse of b. Since x is a random variable, this is an element in f, hence this is well defined actually. So we can show that with this definition R, P of R and P of X is a probability. Induced probability space by a random variable. So in other words, the random variable has its natural space attached to it. If I have this, then what would be the distribution function corresponding to this dx actually? Reduced probability measure. Let's f of x, and it should be x of minus infinity. Okay. What's a discrete random variable? So we say that a measurable map X from omega into R is discrete if X takes some discrete values. Okay, so it takes some discrete values. What is X equal to X? In other words, when X is operated onto omegas, all omegas, I'm going to get a bunch of discrete numbers as an outcome. Okay? I'm going to say that, okay, that's discrete random variables. We know all that. Okay. What would be the px for such a discrete random variable? So I can define px in the terms of the probability of x inverse of these discrete values. Okay. But I can also show. Okay. So if I have a random variable that is discrete, then to each value of x I have to assign some chances actually.
Yes.
Okay. So in other words, I have to assign some chance. Okay. Px operated on the xn actually to each value. Okay. I can call it this is Pn actually. Okay. But these Pns are such kind of a Pns that if you add them, okay, up to infinity, you're gonna get. Okay. What would be the meaning of x being a continuous? So I'm really fast on this. Basically, we know all this stuff actually. So we're not just so I just want to introduce this, this sophisticated notion. Okay, and I want to define the same things, but in the terms of this new machinery that we have developed. Therefore, I'm getting into so intuition, examples, we have done all that. So x is continuous, random variable. If there exists a Borel measurable, a Borel map f from omega into such that the probability induced by this random variable operated on B can be computed as the integral of f integrating over the Borel measurable set B with respect to Hilbert measurable. Okay. So there is a very light point here actually. Why I am emphasizing on this actually. Because I am emphasizing on this. The thing is that for a random variable, it's not necessary, as I said previously, it's not necessary that you can always find a function out of it. So in other words, if a quantity, so in other words, all kind of randomness cannot be necessarily quantified by a function.
Yeah.
Okay? So if you can quantify a function through a Borel map, then you call such a random variable as a continuous random variable. So it's a bit sophisticated version of English. So, okay, if random variable is continuous, if I can quantify the chances through a Borel measurable map actually. Okay. This is what it is. By the way, what would be distribution corresponding to this Borel map? So if I have fx of, for example, x, that would be triangle from minus infinity to x, okay, of f with respect to. Okay. Now, I know that if x is normally distributed, random variable, this is what that we know from our previous knowledge, then I can find a function, okay, which can give us the chances of what? So what would be that function through which I can compute the chances of a normally distributed random variable in being in some interval? Okay, so we f of x equal to e to the minus x minus mu square over 2 sigma square over square root of 2 pi and sigma square.
Hence it is continuous.
Okay, and it's continuous. Okay, so normally distributed random variables are variables whose chances can be put into the form of a continuous and hence a generalizable function. So therefore, I can call normally distributed random variable as a continuous variable. Okay. Lots of exercises, lots of work to do. Very small exercises, you have already done them. Just quickly go through them.
Okay.
Okay, there are a large variety of examples here. I would suggest that at least go through the examples actually. So read them out actually, read them out. I mean, if you think it's too much finance actually, so you can leave it for now. Okay, but at least the mathematical thing I would suggest that read out of the book actually. That's the only way to insist. What would be the next thing that I would like to define quickly? You still have time. Expectation quickly. Okay. let's begin from next week. Take it.
Thank you. Thank you.
Next week.